If we define the short run as the period in which all but one input is fixed, then deriving the firm's total cost function just requires applying some algebra to the firm's production function, holding K fixed at K bar, to get labor as a function of desired output and that fixed level of capital, and then substituting L and K into the expression for total costs, and substitute the resulting L and Q into the expression for total costs. Let's work an example. With this constant returns to scale production function, K fixed at 20, and the wage and rental rate of capital set to 1, Q squared is going to be equal to 2L plus 20. So L is equal to 1/2 Q squared minus 10. We substitute the L and the K back into the expression for cost. Total costs equal 1 times 1/2 Q squared minus 10 plus 1 times 20, or 1/2 Q squared plus 10 for Q greater than or equal to the square root of 20, which is 2 times 5 to the 1/2, or it's going to be equal to 20 when Q is less than the square root of 20, 2, 5 to the 1/2. In general, the cost of producing Q at wage W, rental rate of capital R, and holding capital fixed at K bar is going to be equal to W times 1/2 Q squared minus K bar over 2 plus R times K bar for Q greater than or equal to K bar to the 1/2, or it's going to be R K bar otherwise. The cost of providing the first 4 to 5 units is constant at 20, after which costs rise quadratically. At low levels of output, the firm needs no labor, so changes in the wage has no effect on the firm. But as output rises, labor becomes an increasing share of costs, and a wage increase imposes a greater burden on the firm. At Q equals 2 or 3 or 4, increasing the wage from $1 to $1.50 has no effect. At 6, it would raise total costs by 1/7. At 10, costs would rise by 1/3. Fixing capital in the short run constrains the ability of the firm to respond to input price changes and opportunities to expand output. Consider this new example in which the firm operates 4,000 hours of machine time and 4,000 hours of labor over a year, paying $10 per hour for each. That means it costs the firm $80,000 to produce its desired level of output. Now, suppose the wage doubles to $20 per hour. $80,000, now represented by ISO cost line C2, will no longer cover the cost of producing Q. If capital is fixed at 4 machines, it will now cost the firm $120,000 to produce that same output. But if the firm can add machines and substitute away from the now more expensive labor, it meets its production target. It can meet its production target for, say, $115,000 at point B along isocost line C4. Or consider this firm, minimizing its costs by having chosen to operate with 5 units of capital, but now wanting to double its output from Q1 to Q2. Doing so with fixed capital will more than double its costs. But if it can expand its capital stock optimally, so that it shifts labor and capital to point C, it can expand at much lower cost using isocost line C3 rather than C2. Just how much lower depends on the substitutability among inputs. This graph, taken from Bosanko and Brodigan's micro textbook, summarizes a study by Friedlander and Spady on the total costs of trucking. Short-run spikes in diesel fuel costs have a huge impact on trucking costs. But in the long run, the haulers can mitigate virtually all of the effects by shifting to more fuel-efficient trucks. At least for now, there's no substitute for a driver, so increases in the wage have the biggest long-run impact on the bottom line. So, what's the takeaway from this video? The total cost of production, when only one input is variable, is relatively easy to model. No calculus, just a matter of solving for L as a function of Q and substituting into the expression for cost. Costs rise with output, and the variable input represents an increasing share in those costs. Fixed inputs penalize the firm relative to the long run by eliminating its ability to respond to price changes, or the desire to alter output by substituting toward the relatively cheaper or more efficient input. That means that the short-run total cost function will be everywhere greater than the total cost function, the long-run total cost function, except where the K bar that's been chosen in the short run happens to be the optimal K for producing Q in the long run.